Hey there and welcome back. So the next question that we have is vertical order traversal of a binary tree. This one is tagged as a hard question and it has a successful submission rate of 42%. So let's put our skills to test and see if we can solve this one. I want to take this question slow so that we can maximize our gains from it, the learnings, we can maximize it. So let's read the problem statement and first of all just try to understand what it's being asked from us. Given the root of a binary tree, calculate the vertical order traversal of the binary tree. For each node at position row, column, its left and right children will be at positions row plus 1, column minus 1 and row plus 1, column plus 1. So rows are like downwards, top to bottom, and columns are left to right. So basically, every node is being assigned a coordinate on a grid. The root of the tree is at 0, 0. Okay. The vertical order traversal of a binary tree is a list of top to bottom orderings for each column index, starting from the leftmost column and ending on the rightmost column. There may be multiple nodes in the same row and same column. This is important, so just I'm going to read it again. There may be multiple nodes in the same row and same column. Exact same coordinates might have multiple node value nodes. Multiple nodes might be at the same exact positions. Okay. In such a case, when this case triggers, what we have to do in such a case, sort these nodes by their values. Okay, in the increasing order. Got it. Return the vertical order traversal of the binary tree. Okay, so vertical order traversal is defined in the middle paragraph. We are required to return the vertical order traversal, and that is nothing but a list that follows a certain ordering that is described above. And we have been defined rows and columns and the entire structure of the question in the first paragraph. Now we are given some examples. And so, yes, I'd recommend just pause the video and try to comprehend what is being asked and how we can solve it. Try to stress some muscles on your brains and see if you can come up with an approach or any vague idea before, because that will help as we discuss the approach. So if we look at this, nothing extraordinary is being done. What has been done is every node has been allotted a coordinate as if it were a part of a grid. So what we are going to do is we are going to use the example to understand the problem and devise our solution as we always do. So we have over here like a grid with this point as or the root as origin. So how do we approach this problem? It's a good idea to perform depth first search and keep a track of height and horizontal distance. So what I am talking about horizontal distance is um, this distance. I'll call it horizontal distance. HD, and this distance as we go up and down the tree, I'm going to call it height. So HT. And we are going to perform a traversal as a function traverse, and it is going to be basically a depth first search. This is nothing but depth first search. And we are going to pass node as argument, horizontal distance as an argument, horizontal or height as an argument. And the difference is that for talking about the children, for the left child, what I'm going to do is I'm going to make a call to this traverse function. I'm going to pass node.left as the child. Uh, what is happening from this node to this is height is increasing by 1 and horizontal distance is decreasing by 1, right? So plus 1 and minus 1 is taking place. So that is what I'm going to pass. Whatever the horizontal distance is, I'm going to pass it by minus 1, and height, I'm going to pass it by adding 1 to it. So this is what how a traversal of depth first search for the left child is going to look like. Let's quickly check out the right child. What will happen is for the right child again, plus 1 on height, we are coming down, and in terms of horizontal distance, we are moving rightwards, and on a grid that is plus 1, that is moving in the positive direction. So for the uh, left child, I'm sorry, right child, yeah, right child, I'm going to make a call to traverse function. I'm going to pass the child as node.right, horizontal distance as plus 1, height as plus 1. And this will take care of traversing the tree in the depth first search manner, and as also keeping a track of the coordinates, right? So the main problem is solved. Now what we will do is maybe we can develop some sort of variable. So let's call it variable, and this variable will be a 2D array, and its speciality will be that you put the let's say horizontal distance here and height here, and at that you store the node dot value. You get the height, horizontal distance from here, height from here, and node dot val. As you traverse the tree, you can always develop this table. So this is a table that you will develop as we traverse using our traverse function, which is nothing but depth first search. So now let's move on to the next example where we can actually visualize the case that will cause us some problem. That is when the two nodes are on the exact same coordinate. That is, you see, like we go down, uh, just a second. We go downwards. This is the left child. This is the right child. We go downwards. This is the left child. This is the right child, and we go downwards. This is the left child, this is the right child. And these two children basically are on top of each other. We use to demonstrate, we have widened the gap, and it seems like the coordinates are not coinciding with each other, but in reality, if we follow our algorithm or our approach that uh, going down and minus 1 for left child, plus 1 for right child, then this minus 1 and this plus 1 here gets cancelled out, and this plus 1 and minus 1 here gets cancelled out to give us the exact same 0 comma 0. And the same is true for the heights, plus 1 here, plus 1 here, plus 1 here. So the height for here is 2, and the height for here is as well 2 as well. So let me clean up a bit. So this is the problem. We have the problem as the two nodes are on the same coordinate, and a variable function which was a table uh, which keeps track of horizontal distance and height and the corresponding node dot val is going to not be able to handle multiple inputs, and we need some mechanism to take care of that. So what we can do is, instead of this table to hold values here, what it can hold here is an array, an array of values. So for example, in this case it will hold an array of values as 5 comma 6, and later we can, this time it's sorted, but later we can sort it according to the I'm sorry, we can sort it according to the values, and that is what is required, right? If two nodes coincide in the coordinates, uh, print them in the sorted order of their values. That is requested in the question. So we can do that. Once we have this array, we can sort it. It's not a big deal. But the improvement above that is needed about our table is our table is that instead of storing the values, we are now going to store an array. So this is going to be a 3D table now, three-dimensional table. You give the input as as horizontal distance and height, and it gives returns. And at that position, we have an array of values. So it's a three-dimensional table. And once we have the table developed, we just simply have to do a little bit of sorting and return it in the desired format. So let's hop on to our editor and program it there. So let's begin the coding. First of all, I'm going to declare the result array that will store the output and we will return at the very end. And map is equal to an empty dictionary. Map is the term we use in C++ and Java. In Python, we call it dictionary. Same thing, no difference. And then we will define the traverse function, which is basically the depth first search traversal. It is going to three inputs as discussed: HD for horizontal distance, HT for height. If there is no node, that is if node is none or if not node, I'll simply return. However, that is just the base case. Proceeding, what we will do is if horizontal distance not in map, that is if horizontal distance is the first time we are exploring, what I want to do is map HD is equal to a new empty dictionary or map. So now it's 2D, but we have to make sure that it's 3D. So now if the height is the first time, if this height is the first time we are going through, that is it is not in the map yet, what we will do is we will set the map horizontal distance height equal to an empty array. And if these were the cases for extending the structure of our map. So if we are for the first time reaching out to a new horizontal distance, we will add it and extend our map dimension. And if the height is something we are going for the first time, that is again there is a change in the dimension of map is required, and that we do it in the second case. But that is just the changes in the dimension of the map. Moving on, we need to fill the map as well. So what I'm going to do is map hd comma ht at that coordinate. I'm going to append the node dot val. So now this is a 3D map, and the above two conditions will keep changing the dimensions of the map as required. So now I will make the traversal to the left child. So I'll pass node dot left, hd minus 1 because we are moving leftwards, and height plus 1 because we are going downwards. Now also I'll make a traversal call to the right child, recursion call, depth first search. So node dot right, hd plus 1 because we are going rightwards, ht plus 1 because we are going downwards. And now this traversal function is done, and it does the main core requirement. It solves the main core requirement of the problem. It has developed the 3D map that we needed with the coordinates. Now all is left is to just arrange them. So let's print the map and see what do we have over here. Um, so the first key value shows the horizontal distance 0, and then the first key value inside, that is the second key value, the key value inside the key value shows us the height, and followed by an array that contains the node values. So at 1 comma 1 we have 20, 2 comma 0 we have 15, minus 1, 1 comma minus 1 we have 9, 1 comma 1 20, 2 comma 0 is 15, and 2 comma 2 is 7. And of course, this is a wrong answer as it shows. So let's complete the code. It's not complete. We were just checking out the map. So I'll remove this. So for displaying the output as desired, what I'm going to do is I'm going to sort the map keys. So, and I'll iterate it. So for I in sorted map dot keys, this is going to be sort by the horizontal distance. So I am iterating over the map in a sorted manner with respect to horizontal distance. L equal to an empty array and j in sorted map I dot keys. And this is sorted by height. So in this loop, I'll use j variable to iterate over sorted elements of the map sorted with respect to height, and everything is already sorted with respect to horizontal distance. So now I have the elements being iterated in a fashion in which it is sorted by height and horizontal distance. And this L is the array, so I'm going to extend it by appending or adding the elements from map I comma j in a sorted manner, because this map I comma j contains an array of coinciding coordinate node values, and I want to sort it and append it or extend it to L. And at the end of it, I want to append L to result. And finally, I'm going to return the result as the final output. Now I'm going to quickly run the program and check if there is any error or typo. No, there's not. So now I'm going to submit the code, and perfect, it works. That is it. That is how you perform a vertical order traversal on a binary tree. So if there is one thing that you should keep a note of, is the way we used horizontal distance. It was the game changer. It was something we never used before, the logic of keeping a track of horizontal distance, how far towards the left or right you are while you're traversing every single node of the tree. So keep a note of that, I would say, and with that this problem is solved. Thank you for watching this video.